All right, here we have section 6.5, rhombi and squares. So our main ideas in vocab. So two new vocab words, rhombus and square. So a rhombus is a quadrilateral that has all four sides congruent. It's also a parallelogram. So opposite sides parallel, opposite angles are congruent, opposite sides are congruent. Since all four sides are congruent, opposite sides are guaranteed to be congruent. So here's our theorems for rhombuses, or rhombi is the plural. So 615, diagonals of a rhombus are perpendicular. 616 is the converse of that, which says if the diagonals are perpendicular, then it is a rhombus. And then 617 down there, each diagonal of a rhombus bisects a pair of opposite angles. Okay, so example 1 here. Use rhombus QRST and the given information to find the value of each variable. Find y if measure of angle 3 is y squared minus 31. So here's angle 3, and we want to find the value for y. So since this is a rhombus, the diagonals QS and RT meet at a right angle because they're perpendicular to each other. So if that's 90 degrees, so is angle 3. So y squared minus 31 is equal to 90. So add that across. Y squared equals 121. To get rid of the squared, you take the square root, which gives you y is equal to 11. All right, so down here, find measure TQS. So that's this angle here. So it's this guy. That's what we're looking for. If measure angle RST, so this whole guy here is 56. So since this is a parallelogram, angle RQT and RST are congruent. These are opposite corners. And since it's a rhombus, this diagonal QS cuts these the corner at S and the corner at Q in half. So if this whole thing is 56, half of it, 56 divided by 2, is 28. So measure angle TQS is equal to 28. Okay, if your quadrilateral is a rhombus and a rectangle, then you have a square. So remember, rectangles have 90-degree corners. Rhombuses do not have to. So rhombuses combined with rectangle gives you a square. So all the properties of this should probably say rhombus, of rhombi and rectangles can be applied to squares. So everything that's true about a rhombus is true about a square. Everything that's true about a rectangle is true about a square. Okay, example 2 here. Determine whether a parallelogram ABCD is a rhombus, a rectangle, or a square. List all that apply. So actually the easiest one to do check first is to check if it's a square. Because if it's a square, it's both a rectangle and a rhombus. And then so you know those two automatically. So to check if it's a square, we need to make sure that these sides are all four same lengths and the corners are all 90-degree corners. So to check the corners first, we're going to use the slopes. So to go from, for example, C to D, that's up 2 and over 4. So that's 1/2 if you reduce it. This one's also 1/2. This one is down 4, right 2, so that's -2 and -2. So this is a rectangle because opposite sides, the product is -1. So -2 times 1/2 is equal to -1. So it's for sure a rectangle. For it to be a rhombus, the four sides must be the same length. Now, you need to do the distance formula, but the other way to do it is you can look at the XY pairs on opposite sides, or the combination. So this is 2 and 4. This is 2 and 4, this is 2 and 4, this is 2 and 4, which means these lengths are all the same, because it's the same pattern to get all the way around, 2 and 4. So since all sides are equal, it is a rhombus. All sides congruent, so it gives me rhombus, and since I have a rhombus and a rectangle, I have a square. So this shape is all three of them. It would classify as a rhombus, it would classify as a rectangle, it would classify as a square. All right, last example here, I believe. Example 3, the infield of a baseball diamond is shown, or as a square, as shown to the right, is the pitcher's mound located in the center of the infield. So here that gives you this diagonal, 127 feet and 3 3/8 inches, and then the distance from home to the pitcher's mound is 60 feet 6 inches. So if that's dead center, this distance has to be half of that distance. So I can take right off the side here, 127 feet, 3 3/8, and divide by 2, and does that equal, 60 feet, 6 inches? Well, I mean, you don't even really have to do the math, because 60 feet is half of 120, and that's 127. So no is actually closer to the home plate. Than second base. So it's actually shifted slightly towards home as opposed to being dead center. And that's the end of the section.